Good day, grade 11 learners! Welcome to session 4.1, Solving Problems Involving Circles and Its Properties. This session is especially made as continuation to session 4 about circles to give you some ideas on how to solve problems involving circles and its properties. Our specific objectives for this session is solve the standard equation of the circle satisfying some given conditions. Let us have the following problems. This will be the problems that we will solve for this session. We only have one problem, but we have 4 sub-problems under this. So our problem is to find the standard equation of the circle which satisfies the given conditions. Condition 1, center at origin, radius 3. Another is a circle with a center at origin again, but with a radius of 4. Next, we have a circle with a center at 2, 3 and a radius of 2. And the last one, which we are going to solve, is a circle which is concentric with x squared plus y squared minus 2x plus 4y minus 1 equal to 0 and has a diameter of 6. Alright, let's begin. Alright, so let's begin solving for problem 1.a. We are given a circle with center at the origin and radius of 3. So what are we going to do with this? How are we going to solve this problem? How can we find the equation of this circle in standard form given that the center is at the origin and the radius is 3? So to recall, the equation of a circle is, standard form of the equation of a circle is x minus h quantity squared plus y minus k quantity squared equal to r squared, where r is greater than 0. So in here, in the standard form, the h and k in the equation is the center of the circle and r is the radius. So going back to the given in 1.a is that the center, the given details is that the center is at the origin. It means that it is 0, 0, and that our radius is equal to 3. So to find the equation of the circle in standard form, we just need to substitute these values to our equation, alright, in standard form. So we have x minus 0 quantity squared plus y minus 0 quantity squared equal to 3 squared. Because our center, the x coordinate of our center is 0 and the y coordinate is also 0, it means that our h is 0 and our k is also 0. That's why we have here x minus 0 quantity squared plus y minus 0 quantity squared equal to 3 squared. And simplifying that, we have x squared plus y squared equal to 9. So this is the equation of our circle in standard form. So as you can see, if your center is at 0, 0, then you can just write the left side of the equation into x squared plus y squared, because you don't have anything to deduct from the x and the y here. In both binomials, that's squared. So you can just have x squared plus y squared, and then you square the given radius, which is 3, and that's equal to 9. So there you have it. We already have an answer. Let's try to check problem 1.b. Problem 1.b. This time again, we are given the center of the circle at the origin, 0, 0, and a radius of 4. So the same thing, we have x minus h quantity squared plus y minus k quantity squared equal to r squared. As I have said, if the center is at the origin, that's 0, 0, you can automatically write, this is our solution, you can automatically write x squared plus y squared equal to r squared. And then substituting the value of your r, which is 4, you square that, you have x squared plus y squared equal to 16. And this is the equation of our circle in standard form. Right? Now let's proceed to problem 1.c. Problem 1.c, center at 2, 3 and radius 2. So obviously, we cannot anymore just write x squared and y squared directly at the left side of our equation because this time our center is at 2, 3. Therefore, given the center at 2, 3, this means that our h is equal to 2 and our k is equal to 3. And we have a radius given, and that's equal to 2. So let's try to solve that. Solution. So we have the standard form of the equation of a circle is x minus h quantity squared plus y minus k quantity squared equal to r squared. So with that, we have x, substituting the values above, we have x minus 2 for h quantity squared plus y minus 3 quantity squared equal to 2 squared. Alright, so solving that further, we have x minus 2 quantity squared plus y minus 3 quantity squared equal to 4. And this is the equation of our circle in standard form. Okay? Let's proceed to problem 1.d. Problem 1.d. Our circle is concentric with x squared plus y squared minus 2x plus 4y minus 1 equal to 0, and it has a diameter of 6. Okay? So the first thing that we're going to do here, let's write here solution. When we say concentric means it's a circle which is having the same center with this circle that we have this equation given to us. Okay, so the circle with the equation x squared plus y squared minus 2x plus 4y minus 1 equal to 0 has the same center as that circle we're trying to solve. We're trying to find its equation, corresponding equation. So therefore, the two has the same center. Saying so, to find the equation of the circle, which what we are looking for, we need to first find the center of this circle, which is concentric to our circle. Alright, so since they are concentric, therefore, x squared plus y squared minus 2x plus 4y minus 1 equal to 0. Let's try to find the center of this. To do that, we need to express this into, rewrite this equation into the center radius form or the standard form of the equation of the circle. Because as you can see, this equation is in general form. This one, this is written in general form. Right? As you can see, 0 is on the right and the rest of the equation is on the left. Okay, all the values not equal to 0 is on the left. So here, rewrite this into standard form. The standard form is x minus h quantity squared plus y minus k quantity squared equal to 0. To do that, we need to group together the terms in the equation with the same variable. So we have x squared minus 2x, one group, plus another group is y squared plus 4y, and then move our constant here to the other side, we have 1. Okay, and then using completing the square, we need to express these binomials into perfect square trinomial. So x squared minus 2x. To find the third term, we just have to as I have already presented in the previous session, we just have to get the constant of the second term of the binomial, divide that by 2 always, and then square. So we have 2 divided by 2 is 1 squared, 1. And then for the other, the second binomial, we have 4 over 2 squared. That's 2 squared, that's equal to 4. Therefore, we have here x squared minus 2x plus 1. And then on the second binomial, that's y squared plus 4y plus 4. Okay, so these two now are perfect square trinomials. Now remember, and this is the common error of most students, whatever you add on the left side of the equation, you also need to add that to the right, okay, to maintain equality. So this is 1 plus 1 here plus 4. Okay, now the next thing that we're going to do is we express this into square of a binomial. So to find the binomial, we just need to take the square root of the first and the last term. The square root of x squared is x, the square root of 1 is 1. And copy the sign of the middle term, so minus, and then you square the quantity. Plus, the same thing, y plus 2. Square root of 4 is 2, square root of y squared is y, and then the sign at the middle term is positive, and then you square that. And this is equal to 6. Therefore, the center of the circle, which is concentric to the circle we are looking for, is 1 and negative 2. Okay? Negative 2 because this is supposed to be y plus 2 should have been y minus k, if you can remember, diba? So since it is like that, this must be y minus negative 2. That's why it becomes y plus 2. Okay, I hope you can still follow my writings here. It's kind of messy already. Anyway, so the center is at 1, negative 2, and the radius is square root of 3. I mean, no, this is not square root of 3. Let me check that. So I have square root of 6. Okay, that's square root of 6. But we don't actually need the radius. We only need the center. So this time, the circle now, let's proceed to our solution for the circle that we are trying to find. So I'm going to make a wall on that. So therefore, our center here for this circle which we are looking for is also 1, negative 2 because the two are concentric. And the radius is, the diameter is 6. If the diameter is 6, then the radius is 3, right? Because the radius is half of the diameter. So to find the equation of this circle, because we already have the center, the details of the center, the coordinates rather of the center, and the radius, which is 3. Let me write that correctly. That's S. So using the equation of the circle in standard form, which is x minus h quantity squared plus y minus k quantity squared equal to r squared, we now have x minus 1 quantity squared plus y plus 2 quantity squared. Be careful with that. This is actually the most common error of learners. You forget to also give attention to the signs here, the operation. So because this is negative k and you have minus 2 here, so this must be y plus 2 equal to the square of 3. Okay? You can just have this as your final answer, or you can rewrite this into x minus 1 quantity squared plus y plus 2 quantity squared equal to 9. And this is the equation of the circle. Therefore, we can also say that this circle, this one, is concentric with the given one, this one. Okay? Meaning they have the same center, and their center is at 1, negative 2. That's it, math learners. We are through with session 4.1 on solving problems about circles and its properties. You can now proceed to session 4.2.